Cool. All right, we're live and we got video. So thank you for that. Welcome to the Philly Azure Meetup for February. I have it, it's up on the screen. So I have it up on the screen for the slides, which we'll switch to in a minute. We have a great meetup this month. First, we'll go through the usual agenda. We have some brief announcements, and then two. You're right. I don't have that going on in my background. Apologies to everybody. I don't have that changing slides, and I don't know why. Because I'm on the wrong page. There we go. We have our normal agenda. We will have brief announcements, and then two awesome sessions tonight. Introduction to Data Science on Microsoft's platform with Dave Voyles of Microsoft, and Azure Data Catalog with Zack Fanelle. Brief announcements to run through. First, actual real Azure announcements, which is Azure Event Grid went GA, I think, last week. So if you haven't seen this, definitely check it out. Look it up. Azure is always changing, and we all need to be aware of all the new stuff that's coming out, whether it's introduction of something like Event Grid or add-ons to existing products, say DSA for CDN, which was something that came out in July. And hopefully will be included in a session later this year. Our next monthly meeting is going to be March 13th. It's already live on Meetup, so please sign up. We're going to have a session on SQL Azure and a session on Azure Functions. Briefly, this is more for the room, but also if you are live online on Mixer and want to raise your hand or something in the chat, if you are looking for a job or if you are looking to hire for a job, you can raise your hands, look around. All right, talk amongst yourselves afterwards or while we're doing the minor intermission between the two sessions. And we also have our awesome sponsor, Nexinet, who is also looking to hire as well. And then we have our speakers. So just a couple minutes with Nexinet. Thank you so much for sponsoring. Go right ahead.
Thank you. Yeah, this will be short and sweet, 2 seconds. So first, thank you, Tim. We are looking for good talent always, particularly in the Microsoft space. We're excited to sponsor it as a new meetup. You know, it's great to see this grow, and we hope it continues to grow and that we can be a part of it. Apart from that, the only other thing I think I'd say is if people afterwards want to maybe meet over at Mackenzie's or something like that, I'd be happy to buy the first round as part of the sponsorship. So let's hopefully a great night. Looking forward to the presentations, and that's it.
Thanks so much. So up first, we have Introduction to Data Science on Microsoft Platform with Dave Voyles. So can you switch over to you? And I will get out of mine.
By the way, I'm also happy to see that I'm not the only Mac guy at Microsoft.
No, not at all.
So, good stuff.
Yeah, I am a Microsoft employee with a Mac, which, is this streaming right now? Or my it says Mirror Malvern Room.
I'm only hitting that screen right now. Excuse me.
You have to go over either the AirPlay to this one,
Okay.
or you can plug in.
Hang on. So when you switch between the Mac and the...
So what's my best bet here? Oh, there we go.
Here we go.
Is that our best bet? Do we use that or use this? Oh, there we go. Beautiful.
You got him.
So my name's David Voyles. I'm technical evangelist at Microsoft, which I would say is like a developer who talks to developers. And I used to see a lot of you all the time when I was here, but maybe 6 months ago they rebranded our team, so it's a little bit less community evangelism, at least for my specific role, and now more software engineering than anything else. So I'm still here in Philadelphia, but I tend to live on an airplane more than I did before. Like you said before, I am using a Mac. So they give us Surfaces or Surface Books, but a lot of us also have Macs largely because we have to jump between projects. So for example, I just finished a mobile app with the US Olympic ski team, but I had to build an iOS version of it, so I needed a Mac. I did a project in New York with Docker like 3 months ago, and so it's Docker and Microsoft. I'm thinking, oh, everyone's gonna have a PC? No, I was the only person who had my PC there. Everyone had a Mac. And then after that, I said, I'm just gonna bring both every time. So now it's like I've got the best of both worlds, a Surface Book and a Mac, and I bounce between them. But for all the data science stuff that we're going to do today, it's essentially platform agnostic. It's not going to matter if you use Linux or Windows or Mac. Whatever your flavor, it is all going to work. That's a huge benefit of this. So like I said, I was doing a lot of software development and engineering, and in the last maybe 9 months or so, I've been doing a lot more data science and machine learning. Are there any of you who are doing machine learning or deep learning at work? Okay, so a couple. How about AI, like the larger umbrella? Okay, perfect. We've got a lot to cover then. So it's a somewhat complicated topic, so this one's going to take a little bit of time. We have about 1 hour, right? Okay. I could easily fill an hour. I was at Georgia Tech in November. We did a 3-day workshop. So I did about 6 hours each day over 3 days. So we can definitely fill an hour of this, no problem. And the reason I wanted to cover this was largely because switching from software development to something like machine learning was a huge learning curve. And I found machine learning and data science largely be an overlap of mathematicians and software engineers, and then machine learning is kind of right there in the middle. So have any of you like at least investigated some of this, maybe done some Udemy courses or Coursera, anything like that? Okay, perfect. So at least looks like people are starting to dip their toes in there. That's good. What got me interested in this was last year I was in Atlanta at an event called Dev Nexus. And Microsoft put on a workshop with NVIDIA, who makes obviously most of the GPUs, graphic cards that we use, not only for things like PCs and gaming consoles, but also for self-driving cars. So we put on a machine learning, specifically deep learning workshop, where we brought all of this hardware on site, set up these workshops, and we had a line out the door both days. And this was at a developer event. So everyone just getting really interested to understand how deep learning worked. In this particular case, we're doing something with OpenCV, so computer vision, to do object recognition on these tiny, tiny computers called NVIDIA Jetsons, Jetson. And when I saw that demand at a developer conference, largely geared towards web and mobile, I realized, oh, okay, we might be on to something here. So that's when I dove in with both feet and started to learn about data science and machine learning. Now, 4 years ago, when I came to Microsoft, we had a real big change because we were just getting rid of we're changing CEOs from Ballmer to Satya Nadella. So it was a huge shift, right? Went to, whatever Microsoft was doing before that point to now cloud first, mobile first. And in the last maybe 6 to 9 months, it's really been cloud and now we'll say artificial intelligence as a whole. So I don't have a board to draw on right here. This is when I really do wish I had my Surface Book, because I love to kind of draw on the board. I would illustrate exactly where AI, machine learning, and deep learning sit. So let's see, AI, ML, DL. Let's see if I can find a nice little image here that overlaps. Beautiful. This is exactly what I'm looking for. Thank you, Google. So look at artificial intelligence as the big bubble, right? It's the whole shebang, covers quite a bit. Machine learning is a little more specific in how you're going to use it, the tools you're going to be using, the algorithms you're going to be building. And finally, deep learning is the smallest subset of that. And it's smaller because it's very difficult to find people who truly understand deep learning, but it's also difficult to find use cases for it too. There's certainly many out there, but not everything is a data science or deep learning project. And I keep using that term data science because I think it's something that not everyone can agree on and what it means specifically. So I've just gone through tons and tons of books in the last couple of years, and what seems to boil down to, right, data science is trying to make sense of all the data that we have today, all right, in some way, some fashion, whether that's looking at statistics, really drilling down and analyzing them, but also using the tools at our disposal to make sense of them. And one company more than any other out there right now, it's really taking advantage of this is Netflix, right? Most of us either subscribe to or have used Netflix, and they are a mile ahead of the competition in terms of video streaming, largely because of how well they can understand what the users are doing. So they are miles ahead of the competition. Amazon, even with their video recommendations can be hit or miss, but their store itself does a fantastic job of recommending items to you as well, and that's largely because they have so much data on everyone. That's the key point here, data science. Tons and tons of data. We're collecting everything from IoT and different sensors, the device you carry around, and now we need to make sense of this. And a large reason we've seen a big rise in data science and machine learning in the last couple of years is due to this device right here, right? The graphics card, the GPU. So these were previously just used for video games, right? Displaying beautiful graphics. And it's a very niche market at that point. But now, I mean, even the price for this card, I bought this card 2 years ago for $450. And now, right, computer hardware typically gets cheaper over time. These have done just the opposite, right? This is $750, and I'm amazed that it even has any in stock, because up until last week when we had that stock market dip, these things were sold out for months. And that's because people were using it for machine learning projects, but largely for things like mining Bitcoin and cryptocurrencies. Even I pulled up a Wall Street Journal article that I was reading this morning about Bitcoin Mania triggers miner influx to rural Washington. And this is not limited to Washington state itself. This is all over the country, largely the world. But this article, which I'll give to you folks after this for the show notes, actually, I'll put it in Mixer right now. WSJ. So that article will actually, how deep in the matrix can we go? Talks about how much power some of these devices are consuming. And there was a great infographic. Here we go. Power use per square foot. Here we go. So these computer data centers. This isn't any computer data center. These are the ones that people are using with GPUs to mine for currency. So interesting time to be working with graphics cards to be doing machine learning. So getting off of that, you look at this, we see these GPUs are very limited at this point, and they're very expensive. We can do some machine learning on our devices locally right here. I have a MacBook Pro with a very small, discrete graphics card in here. I can also do a lot of machine learning on the CPU that's running on this device as well, but I'm not going to get nearly the performance that I could get by running on a graphics card. You with me so far? Perfect. All right, so we see artificial intelligence, machine learning, deep learning. I'll briefly cover all three. So artificial intelligence, a program that can sense, reason, act, and adapt. It sounds like Skynet, right? Kind of getting smarter and smarter over time. Really, it's tools like Azure Cognitive Services. So these are just some of the Microsoft suite for different tools that we have available as part of our cognitive services, or AI, that you can take advantage of today. Things like vision, knowledge, language, which you're using for things like bots, speech, search. So vision, I'll click on this. Right, we have our computer vision API, right, distill actionable information from images. So what we can do is we can pass in images. So I'll try this right now. I don't want to quite get the key yet. I want to just try this out. Let me see. No. Let me go back. So I don't want to actually spin this up myself. I want to try. No. Of course, when I finally need to look for it. What I'm actually looking for is our website, so that I can literally just try this out without having to log it in by simply passing it an image, and then it'll give me JSON data back. But one of the downfalls of being on the cutting edge of technology, that these things change so quickly that even the web portals change. So use an Azure subscription. Let's see if this works. So rather than design these tools yourself, what we can do is, with our cognitive services suite, we can build on all the data that people have already given us. So with things like the computer vision API, I can give this an image. I don't know why it's bringing me to the portal. Say Azure image recognition face. Here we go. This is actually looking for the face API. So what I can do here is I can actually give this someone's face. Let's look for Tom Brady. We'll be nice today. Look for Tom Brady's mugshot. Tom Brady. Now I'll go to the face API. I can pass the URL, which I probably should have just done, but in this case, I'll actually give it the image itself. Oh yeah, now that I'm streaming to this, it's gonna get all funky on me. So to give it a moment, it's going to take this image, go up to the cloud, use all the data that we currently have stored based on images that people have given it to us previously, and it's going to return a bunch of JSON. See, in this case, the previous image, it said verification result, the two faces belong to different people. And it's giving me a little bit of a confidence interval. So this is how sure it is of that. What I was actually looking for here wasn't quite this, but it was definitely, here we go, the face detection. So with this face detection, I can do the same thing. I can upload an image. Let's go Tom Brady. This is what I was looking for. Again, that first API wasn't even there the last time I checked a couple weeks ago. So with this, I'm going to give it that same image. It's going to come back with tons and tons of detail about this individual, right? Hair, bald, or hair color, what color are the person's eyes. So here we go. I pass it up an image. So in this case, I'm just doing a post, giving it the image. It's giving me a bunch of data. You would hit this the exact same way, but with your developer key. I've really got to be careful with how I'm spinning around my mouse here because it's kind of covering up quite a bit. So in our case here, we can see that it says that person most likely seems to be bald, invisible, false. I'm not quite sure what that is. Hair color believes this person's hair is brown, and it says that with 1.0 confidence. So it is certain that Tom Brady's hair is brown. I think we mostly agree to that. Let's scroll down a little bit more here. Okay, believes with 0.567 confidence that the person is actually smiling. Looking at the head pose, and it can control or understand what kind of pitch, yaw, and roll a person has. Gender, male, thinks he's 31.5, right? At this point, hey, maybe he was. He's 40 years old, still playing the NFL, so he's got that all-American, boyish good looks. Picture. Yeah. Definitely not wearing any glasses. So we get all of this data back from simply posting an image to this endpoint. Mm-hmm. So now, rather than us have to go out and write this ourselves, probably in something like Python, which most of the machine learning tools seem to be written in today, we can simply hit this endpoint, and it's already done for us. So at a lot of the hackathons or game jams that I'm working at, this is fantastic, right? It's an out-of-the-box solution. It's not real time. It's going to take a few moments for it to come back, but if you don't need something done in real time, it is a fantastic alternative. Mm-hmm. Face detection, similar face search, face grouping. I'm sure many of you are familiar with Facebook, right? I can assure you they have their own set of tools that are doing this exact same thing. That's why when you post an image there, regardless of what kind of hue is happening to your face, they're still able to detect that it's you. I took a photo in Montreal like 3 weeks ago, and we're in a room, like an arcade, where had tons of red light shining on our face. And someone who I wasn't even friends with added the photo, didn't tag me in it, and I still got a notification saying, "Is this you?" I was like, holy cow, like my face was red like this keyboard because of all the light shining on us, and it's still determined it. And that's largely because they have great deep learning tools that can kind of pan and scan across each pixel of an image and determine patterns. I may not have too much time to go into that just yet, but that's how they're doing it over there. But I just wanted you to be aware of some of the cognitive service tools that we have over here. If I go back a bit more, so cognitive services, think of artificial intelligence, right? A lot of the smart tools we have. Bot framework, have any of you used that before? Okay. Microsoft Bot Framework. I have a blog, by the way. It is simply my name, davevoyles.com. So what I find is easier, just Dave Voyles Bot Framework. I have a blog post on exactly how this works. I've given overviews on this before. I've actually built a question and answer bot in about 15 minutes. Put all the source code on there, explain step by step on how this works. Imagine you had an FAQ on your website, right? Rather than blow people off every time they have a question and say, oh, I've already answered that over here, it's in this text. You could simply say, well, I have a bot that can answer your questions. Now the users who go to your site are more engaged, right? They feel a little bit more loved. So what I did was put together a bot for this. And for whatever reason, my site's not loading right now, or at least that page. But at least you can see hopefully the code is still up there on GitHub. I open source as much as I possibly can. Bot. PHL Reactor bot. So I built a very simple bot. Even on GitHub, I have all the instructions. And look at our bot framework, right, as another artificial intelligence tool that you can take advantage of as well. We're finding large customers using this for customer service, or starting to route people in the correct direction before the customer gets to actually speak to an individual. Saves lots of time, saves lots of money. I came from Comcast before this, and you better believe they're all over bots right now because they're trying to cut down on those costs to have more efficient processes too. So I'll come back to that. So now we have artificial intelligence done, but I want to get into the good stuff, machine learning and deep learning. So the first blog post that I have, or the one I most recently updated, was getting started with data science and machine learning in Python. So let's get into that. So what I did was I put together a bunch of useful libraries for data visualization. And I often create these blog posts, not necessarily for all of you, but selfishly for myself, because I find it a good way for me to keep track of work that I've done over time, but also to kind of answer a lot of my own questions. So in terms of these libraries, what I was doing was I was going through Udemy courses all the time, and I'll briefly cover those and how they work. But I was taking all these video courses, and as I'm doing, coding alongside with the videos, I'd see these frameworks or libraries come up over and over and over again. And I just didn't understand how they all related to one another until I saw this image and realized, okay, with data science and machine learning, NumPy is the lowest level, okay? It is, you're gonna be using Python for most of this, and NumPy's, all these frameworks, I should say, are exposed to you with Python. But don't be concerned about speed just yet, because what a lot of this is, in actuality, is actually C++ just exposed to you with Python. So you're not having to deal with all the craziness from an older language. Instead, you can just get stuff going, get up to speed as fast as possible. Remember I said at the beginning that a lot of people working in machine learning aren't necessarily software engineers, right? A lot of them might be statisticians or mathematicians, so you can't expect them to all understand immediately how something like C++ works. Pointers and passing by reference, but at the same time, Python, much higher level, very easy to get going. So that's why I find it was a great language, at least for a lot of these folks to start with. You also hear R would be very popular, MATLAB. I don't think you can go wrong with any of these, but I'll be honest, I think Python is probably your best bet to get started, especially if you're already a software developer. So look at NumPy as the Python framework for numbers and Python together. Does a lot of the crazy math that you wouldn't want to write yourself. Building on top of that, we have things like pandas and matplotlib. So pandas have a little bit of notes on most of these up here. So pandas, built on NumPy, adds tons more. Rich time series functionality, data alignment, group by, merge, join methods. So again, a lot of math and functionality you wouldn't want to write yourself. And this was actually put together by a gentleman who worked in finance, found himself having to do the same things over and over and said, I'm just going to write a library for it. So for the most part, NumPy, you're probably not going to be working with, but you're still going to want to understand why it's there and that it exists, because a lot of the tutorials you'll see, especially the video ones, will use it. You'll see how much work all of this was, and then they'll say, oh, by the way, we have pandas that does all that and then some. Which was frustrating because I'd spend 2 days going through a video course only to find out that say, oh yeah, I just wanted you to see how it works. So pandas will be very helpful. You'll use that all the time. Matplotlib, I cover up here a bit more. Generate plots, histograms, bar charts, error charts, scatter charts. You will use this all of the time for visualizations. And I'll show you exactly how I use it in a moment as well. SciPy, I use from time to time, but more than anything, on top of that, you see they have something called scikit image. There's one that isn't included here, or scikit-learn is actually what I'm looking for. Scikit-learn, and I actually say it right here, I always use this. If you're doing machine learning, scikit-learn will be your best friend. This way it abstracts so much of the math, so much of the algorithm building yourself, that you can actually take advantage of these tools. And the reason I'm telling you this, the reason I put this together, was because a year ago when I was just getting into all this, I looked for Coursera, Andrew Ning. This gentleman, American computer scientist, he worked at Google, Stanford, Carnegie Mellon, and now he also started Coursera, a great online learning resource, a couple of years ago. And he had this course that he put together, just called Machine Learning. take a look at this, but don't do this. I'll tell you this as someone who went through it, and it's probably 7 or 8 years old at this point, and I would hear everyone say, oh, this machine learning course is fantastic. Do this. It'll be so helpful for you. The first week, I'm like, okay, I got this. Second week, boom, wall of math. My undergrad was communications, kind of a bad degree to get. I tried going back. I did a year of an MBA, so a bit of math. But when it came to doing crazy math like this, yeah, you're not going to stand a chance, I assure you. If it had been more clear to say, like, master's degree in mathematics required, no problem. But the symbols get so difficult, long, and complicated that you couldn't even Google them. So I had to keep taking a screenshot, emailing friends who had master's degrees in math and say, what is this symbol, so I can Google it. Completely serious. So I did a bit of that, and I realized, like, wow, I'm just hitting a wall. Although, in all fairness, the folks who do work for Coursera, who are on the message boards, they'll answer your questions in incredible detail. If I wrote 2 or 3 paragraphs about a question, they'd respond with 2 or 3 pages. Often, for some reason, with handwritten notes, and they'd like take a screenshot of it and then put it in there. I don't know why. But I saw this and thought, oh my goodness, machine learning is not for me. No way. Then I came across some of these other courses when I realized, okay, this Stanford course is fantastic if you are the researcher writing the cutting edge algorithms that everyone else in the world is going to be using. It's like, imagine if you were the engineer working at Microsoft to build the compiler for the tool. If you want to write compilers, this is the course for you. If you want to be the person building the applications the world is going to use, no, this is not for you. So he has updated it, though. There is a new course that he just came out with that I've actually got to take a look at. I think it's on deep learning, but I've actually heard really good things about this one. So this one, I'm telling you, hang tight, come back when you have a really solid understanding of math, but just understand this one will not be very beneficial for you at your company to make a difference today. Instead, again, I got into that, got really disheartened, said, oh, there's no way I can do machine learning, forget this noise. Then I found Coursera, or Udemy. Have any of you seen Udemy before?
Yeah.
Okay. Have you seen edX, things like that? So I rave about this, not because I work with them or for them, nothing. Just because I bought a bunch of courses. I'll show you in a moment. But you can see, look at all the stuff they have here for $11.99, right? $12, $13, $14 for these different courses. And it's on everything. I mean, it's doing a good job of surfacing things that I would like, largely because of the things I've purchased in the past. But if
Serious discounts.
Yeah, oh yeah. Although I can't ever tell if these things are ever not on sale. Although I'll tell you,
just
for
like you.
Yeah, right? Yeah, like it's like, oh, $150, buy it for $12 today. But I'll tell you, I mean, it works on me because you can see all the different courses that I've bought.
Part of Amazon.
Yeah, I don't.
If you buy it for $100,
Yeah.
they will keep charging you $100. If you buy
for
it on
these?
sale,
Oh, right. Then they'll know, hey, this person waits
It's
until things
cheap.
go on sale. And you can see, like, here are, a bunch of different courses I've done. I've already rated them 5, 5, 5, 4. These are fantastic, especially when you consider how much it costs to go to school right now. I just applied for Georgia Tech's online master's program for
out of
computational data analytics. Yep. But Georgia Tech opened a master's in computer science about 3 years ago, but it was $10,000. So people flooded in right away. I had a coworker go do it, said it was fantastic. And then when he brought that up again a few months ago, I was like, yeah, let me go look at that again. And sure enough, they just opened a degree in analytics. So I applied for that. It's $10,000, but work pays for it if we get a B or better at Microsoft. So I said, I'd be crazy not to do this, right? A master's in data science for free? Okay. But then I looked at other programs. NYU just sent me an email the other day. And granted, I have no desire to go back and forth to New York all the time. That program was $80,000, right? $80,000. I mean, I'm confident with machine learning, data science, you can make the money back. But you look at other programs, Wharton, their MBA program, right? Probably the best in the country, $160,000. That's a nice chunk of money to spend on a degree. Or you could do one of these for $12 and then put it on your LinkedIn and then just watch as the emails start coming in. You don't have to apply for jobs. They will just come to you the second they see machine learning, data science, anything. So I went from like knowing absolutely nothing 9 months ago to going through all of these, often like several times. You can download to your phone, everything else, and they're fantastic. So all the ones that I've gone through, I actually lucked out and that most of them were very good. For example, it's one in the top left corner by Sundog Education, Frank Kane. He actually works on Amazon's machine learning team for serving recommendations. So he explains how they do it at Amazon. Tons and tons of videos. Like, you know, I'll briefly show you what this looks like. If I go to course content, right, getting started, stats and probability, Python practice, predictive models, machine learning. And again, it looks like a lot. Supervised and unsupervised, training and testing, k-means clustering. I went through all of these several times. You know, deep learning and neural nets. Right? This alone, I mean, he has maybe 2.5 hours of just deep learning and neural nets. You could spend 2.5 years and still not understand it all. But they do a fantastic job of skimming the surface, and then you can build that on your own as well. So I had no confidence going to any of this. Now, perfectly fine. I've already finished 2 machine learning projects with partners. Got another one, deep learning project with NASCAR coming up in a couple of weeks. So companies really want to dive into this stuff, but we have a very difficult time.
Figure out when NASCAR is going to run out of money?
No. Somehow they're getting bigger, but I went to a NASCAR race. I actually quite enjoyed it. NASCAR is an interesting bunch. I did a mobile project with one of their teams last year, and my father grew up down south. He loves NASCAR, so I'm thinking, okay, like everyone's got to be a hillbilly or something. And my father was definitely like that growing up. Then actually went down. The people working behind the scenes at things like NASCAR, a lot of them have PhDs. They're coming. Yeah, they are hardcore engineers. Do you have an idea? The people who make the cars, like Hendrick Motorsports, everything that they use on that car, the tools they make themselves. So the drill that you see the pit crew guys do, they don't buy those drills. They 3D print them in plastic first. Then they take steel molds and they build it all themselves. I did not believe it. I got to go through all the workshops and see, and they showed me step by step how all these things are made. It'll blow your mind. That's NASCAR. I had no idea. But I'm saying this because those are the kind of companies that are really starting to take advantage of some of these tools. Even a problem that we have at Microsoft as a whole is we have so few people who understand how all this works, but there's a huge demand for it that they've now allowed us just to fly all over to work on these projects simply because there are so few people who quite understand. So part of my goal in the last few months has been, how do I break this down into terms that other people can understand so that we can get more people involved, but also it's easier for me to work with our customers and partners so that they don't think everything is a machine learning or deep learning or AI project. And I'll get into that in just a moment too. So all these courses, at least the ones that I'd recommended, I have on that blog post. So if I scroll down a tiny bit, I see Udemy courses. I highlight 2 for machine learning. That's Python for data science and ML bootcamp. This other one that I was just pointing you towards a moment ago, I would highly recommend this one. Each course might take you, if you just watch the videos, maybe 6 hours each. But again, they're like broken down into 5, 10, 15-minute chunks. But if you're coding along with them, it's going to take you a little bit longer. When I first started, I was super slow, didn't understand the tools, didn't know the libraries. Now I can watch a video for a few minutes and just say, okay, I got what's happening, and go crank away.
Dave,
Yes.
this Microsoft product, I'm looking at LinkedIn Learning,
Mm-hmm.
which used to be lynda.com.
Right.
They have dozens of like 5-hour courses on
Yep,
machine
look at that.
learning. Yeah, a lot of them. They tell you how to use Python.
And like, I don't know how much those cost or.
Well, I think
You have
a lot of
an account.
companies are starting to look at adding that.
Yep.
Well, for a while, lots of people were getting Pluralsight,
Yeah.
and but now that they rebranded lynda.com, I think you're going to see a lot more people
Yep. Yeah.
use that.
edX also offers the Microsoft data.
Yes.
Yeah.
Yep.
And Microsoft sponsors that as well.
Yeah.
Lots of libraries give you access to Pluralsight or lynda.com as well.
Take advantage of that stuff. So edX, yeah, is
What's a
fantastic
library?
too. I mean, you look at like for all these free courses too.
Free
My wife's a
MIT,
librarian.
Harvard, Berkeley, right? And then all the different courses that you can take through this. I would highly encourage you to try out any of these sites. I've done a couple through edX. I loved it as well. Like you said before, we have like a whole track you can do through Microsoft. And I think there's a free version, but you can also get like a certificate that you can have like attached to, show you that you're accredited for doing this.
At the end, you have a capstone
accredited.
project with machine learning.
Yeah.
If it pass or fail, 70% or above. It's really good.
And it's some work.
Yeah.
And where these have a huge advantage over, universities and schools today is that schools have a very difficult time keeping up with the speed and how these things are changing. And even in the last couple of years, a lot of the folks who were working in machine learning and deep learning came from academia, and now they're being brought on to Facebook, Google, Microsoft. I know we hired 5,000 people last year alone just for machine learning. So a team went from like this big to absolutely massive in a very, very short period of time.
Question online.
Sure.
Question online coming in says, what makes Python so attractive to this subject?
Python. Okay. I think for most people, it is very easy for mathematicians, statisticians to get started in that language because it's so high level. Also, universities are teaching Python more than ever. Previously, when I was working with schools, we found that Java and C++ were very heavily taught. And now I'm seeing a lot of schools leave that in favor for Python. So for example, I went to Cornell last year, and we do hackathons with these students each year that we go. And almost every question was Python. Nothing with machine learning at that point. It was more like, how do I spin up a web server with Python? So I found universities teaching it. I found a lot of people coming from math teaching it. And if you're a programmer writing in C, C++, C#, going to Python is very, very easy because the syntax is far less complicated than other languages. So I think that's probably the biggest change. And then finally, just the sheer availability of the libraries everywhere, right? And there are tools for getting a lot of these libraries. Like I have Canopy opened here. If this pops up, let's see. Sounds like the hide in the background. Oh, of course it is. Okay. So anyway, I have a tool called Canopy. It's similar to one called Anaconda or Conda that people run from time to time. Essentially, it's an IDE with a Python package manager. So a lot of these tools come with a bunch of these packages built in already for you. So for whatever reason it's not popping up for me right now, I may come back to this shortly. So for those reasons, I think Python has like really taken off. And I only started to use Python because all these students I kept working with were using it for everything. So I had to learn how to answer their questions.
Also, Python does run in Visual Studio.
Mm-hmm.
So it's a good IDE, even if you're familiar with stuff,
Yep.
that you can do Python in Visual Studio.
Yep. Where Python gets tricky, for me at least, is that there's different versions, like 2.6, 3.5, 3.6. It's a nightmare to keep those managed. So there are tools like, again, Anaconda, which can manage them for you. But you've got to be very careful when you're looking up these new frameworks to find out, is this framework compatible with this version of Python? Because I know I've shot myself in the foot going down a rabbit hole only to see, oh no, it doesn't work with this version. Okay, so we've kind of covered education, how to get started. So again, for a lot of these edX courses, Udemy, things like that. And the only reason I really showcased the Udemy ones here was because that's what I started with. I kept going down that rabbit hole, and these ones worked really well for me. Building on that, what I will tell you, there's a couple of books, and I'll show you some code too, don't worry. What I'll tell you is these 4 books, I've probably read 20 different books on machine learning in the last year, and these are the 4 best that I came across. First one that I recommend for everybody, Data Science for Business. And this one, because I didn't quite understand all the programming aspects of machine learning so far, or at least when I started, but I read this book. These professors, I think, are also at NYU. This is typically used as a textbook for MBA curriculum at schools across the country, because it'll touch on a lot of the technical parts, and they even break up some of the chapters to say, hey, you can skip this if you don't want to understand the code. But this is how you can pitch machine learning, artificial intelligence, deep learning to a manager, to a boss, to someone who's not very technical. Also, it helps to really define what the problem statement is. I was working with a company in Chicago. I went there twice over the last 2 months. And this book was invaluable when working with them, largely because they had this huge scope of work. They have a warehouse that they wanted to optimize, not the traveling salesperson problem, but instead they want to optimize for warehouse layout and where each item would be stored. So they looked at this and said, oh, machine learning can solve this, just have at it. And I kept telling them, no. We've got to narrow this down. Like, get your problem down to one sentence. What are we going to solve for or optimize here? Went back, forth. And then finally I gave them this book. It went a long way to helping them understand, okay, maybe we don't actually need machine learning to solve this problem. And I'll show you briefly what this looked like. So here you go, Hackfest. Give you an idea for some of these notes, some of the math. Right, so I keep track of everything we're doing along the way. Here's some of the notes, some of the notes. Here's where it gets good though. This was some of our whiteboarding. Thank God for Surface Hubs, because that's where we did all this on. So this was all the math and the planning and algorithms we're building. At the very end, 6 days of this, we realized, okay, this isn't a machine learning problem. So it's all data science, exploration. But yeah, so we kind of realized that the most efficient way to do this was actually to do a bunch of SQL queries and keep making small changes to the way we were searching for this data. But it took several of us a long time to get this done. 2 people in the room had PhDs in machine learning. So where this is very different from traditional programming that we might do, you know, if I build a mobile app for someone, I could say, okay, it's gonna take me 5 days, I'll have an app delivered, here you go, here's all the source code, right? Something like this, machine learning, often you don't have something super tangible at the end of this. It's not something you put together in a day and just say, here you go. Often it's the insights that you're gathering along the way to say, maybe this is the wrong way, or maybe this is the right way to go. So it's helping you make sense of all this data that we have. And in their case, they had a crazy amount of data. They were able to track footsteps for each employee in a warehouse because they have these scanners, and they could track over time who was going where to pick up which item and come back. So we were able to sift through all that data, make sense of it, and realize, okay, let's start cutting a lot of this out. That's an important part of what we've been doing with data science as well, is the algorithms, for the most part, they already exist for you out there. That Coursera course, those are the folks who are writing those algorithms. You will not have to write that yourself. There's ML algorithm use cheat sheet. Here's what I'm looking for. When I saw this, my mind exploded on Microsoft Docs of all places. So here is the cheat sheet.
Mm-hmm.
So it looks like a lot. Let's get this open.
But you need a big printer.
Yeah. So there's really only a handful of algorithms that you could use anyway. There's things like anomaly detection, right? So imagine you're doing buying and selling of stock, or fraud detection for things like is someone misusing a credit card. There's regression, where you're trying to fit data over time to align. There's clustering, where you're trying to put things together into natural groups. There's classification, where we're trying to break things up by class or by type. Multi-class classification, same thing, but instead of A or B, true or false, you might have multiple classes. So looking at all this, you realize, like, oh, okay, I can start here, discovering structure. Okay, so for our warehouse problem, I started with that, k-means. So all of a sudden, all these data points are being drawn onto a graph, and we're trying to figure out, okay, we see that these things are separated, but why are they separated? So all of these, linear regression, neural network regression, these are all different kinds of algorithms. You don't have to understand how all of them work. But if you understand how the 1, 2, 3, 4, 5 main parts work, you have a good starting point, go from there. And often, with a lot of these frameworks, like scikit-learn, you're not having to write this math yourself. Again, you're saying scikit-learn dot linear regression, pass in your parameters, you're good to go. All the magic comes from understanding how that's actually working, where you can make some tweaks. When you get to deep learning, it gets far, far more complicated than that. But when I saw this, it really helped me to understand how all this worked, and that I actually could do it as a software engineer without requiring a PhD. But that is the cheat sheet to get started. I'm not going to go over all the yes, sir.
Being a statistician,
Yes.
it helps to know and spend enough time with each of the algorithms to know where they are appropriate
Yep.
and where they can go seriously wrong.
Yeah.
Because you can throw some things in without knowing that there's cross correlations and other things going on.
Yeah.
That you could find yourself seriously screwed, getting results that appear to be correct
Right.
when they really aren't.
Yep. Yeah. And that's where machine learning starts to get complicated, and where the math background really comes into play, because then you understand that correlation is not causation, right? Or if you're trying to take something that's a class or a type, and if you want to draw, if you want to kind of place them together, you've got to turn them into integers, right? Zeros, ones, so that you can show relationships as well. This book is fantastic for that. So if you get any two books when you leave here, that business one I showed you, and then hands-on machine learning with scikit-learn and TensorFlow. This book's fat. I mean, it's 500 pages, something like that.
Oh,
This thing's massive. It's taken me like 6 months to go through it. I fly a lot though, so it helps out. And mine, I have the physical version, so I beat it up, I highlight it, I write in the margins. They have questions at the end of every chapter. This book is fantastic. There's a reason it's a #1 bestseller in the subject on Amazon. It'll take you some time, but that in tandem with those video courses, you'll be gold. Okay, so we have books, we have some guides. What I will show you are some tools. So this tool, which has saved my life, come in handy quite a few times, is something called Azure Notebooks. Okay, so Azure Notebooks are a Python environment inside the browser. So you can do a lot of this data science locally on your machine. You have to install a bunch of tools. Again, we did this event at Georgia Tech. It was called Data Sci Conf Atlanta. On the first day, we taught TensorFlow, which was a deep learning framework. So this thing was fantastic, but the instructor who was supposed to show up on the first day, I guess, got into a car accident or something. So we had to quickly fill in and start, myself and several others teaching people how all this worked. The first couple of hours we spent was just getting everyone's machine up to speed. So there's about 150 people in the room. It's a big class. Getting everyone, okay, you got a Mac, you got Linux, you got Windows, get this version of Python. Oh, the network's getting killed because it's super, okay, download that. So it's hard to get a lot of people on the same page, especially if they hadn't done a lot of this work before. So that was a painful 2 hours. The next 2 days, when in our own room we were doing data science with Python, it was just myself teaching with about 40 people in the room. The new people who had come in, first day was kind of like the pre-day, then days 2 and 3 was, the course gets twice as large. Everyone showed up, and these people were not looking forward to having to get everything set up. I said, okay, just go to notebooks.azure.com, log in the top right corner. You can go in with your Azure ID. Even if you don't have, cloud credits or anything like that available to you, this runs for free on Linux virtual machines in our cloud. You just make a name when you get started. That's it. So interactive coding in the browser, and it uses a tool called, I don't know, I'm drawing a blank right now. IPython. So interactive notebooks inside the browser. Even better, you scroll down a little bit, we have, they call them libraries, but essentially it's like intro to Python, getting data into the notebook. We did sentiment analysis with tweets. So all of this, and I'll show you exactly what it looks like. Let's look at sentiment analysis with tweets.
It's great.
Yeah, when I saw how easy this was, not necessarily this example, but when I saw how easy it was to get the environment running on my machine without installing any tools, easy. So the font looks kind of small. That's irrelevant at this point. What I want you to just be aware of is these are all cells of Python that I can run inside this machine. So imagine this. I go to hit launch. It spins up a virtual machine. There's actually one running in the background. Somewhere in the cloud has a Linux virtual machine, and I have just an app service, right? An endpoint that I hit that allows me to use those resources. And all those resources, the compute, is made available to me inside the browser. So what you can do is you can look through some of these courses and kind of, okay, I get a gist of what's going on, but it's step-by-step instructions on how this works. But even better, I could hit things like download, and I can run this locally if I have IPython installed. Or Jupyter Notebooks. I should say IPython was the original version. I lost my head a moment ago. Jupyter Notebooks are like IPython on steroids.
It's generic for R and F# and multiple platforms.
Yeah, so I should be clear, it's not just for Python either, and I'll show you exactly what I mean here. So my notebook, available to the public, or I should say my libraries, my notebooks, are just notebooks.azure.com/my name, Dave Voyles. You can see all the different things that I'm doing in here. I created a workspace, right, a logical way for me to keep my things organized, and I throw all kinds of code in there. Some of the other courses that I'm doing, I might put in here. So where was the one that I was doing earlier? I think it was this one. No. I'll come back. Maybe it was this one. So what I'm doing is going back to one of the old libraries I had created with the Python notebook. It's spinning up on a Linux virtual machine somewhere else, and it's going to give me all of this code that I've already written. So you may not want to use this for a production model that you're actually going to give out to someone you're going to work with, but for you to document your code along the way. When I'm doing hackathons and code whiz with partners, it's fantastic because in these cells, I can select Markdown, I can write code. So in this case, I have Markdown right here. I hit Control Enter, and now I have Markdown working beautifully. Go down a bit more, and I can import all the different libraries that I need. It's going to do exactly that. In the background, it's going to do pip install. Pip is Python's package manager. So again, on a Linux virtual machine in the cloud, it's going to install those things, not on my device. And then I could start to display all of the data, start to make sense of it, and I'll go into this in just a moment. I don't want to take up too much time here, though. But a lot of this is just data exploration that I've been doing. So I'm going to go back a bit, and let's do that code with example. So Clover is one of the companies I'd worked with a few weeks ago. So what we did was, on day one, with myself, a PhD in machine learning, and they had 2 database admins. So we're all working together in tandem, and I'm sharing this notebook on the screen the whole time we're sitting there at the desk cranking away on code. And the database engineers kept giving us new data in the form of a CSV. And you can see right here, I would import the framework, the libraries that I need. Remember I mentioned before, pandas, NumPy, matplotlib, right? So I can do my visualizations. And then all the data that I would import, right? All I'm doing is saying, pandas, I want you to read the CSV. I have a CSV stored in a data file, also in this virtual machine. And I can get some insights in this data, right? So I'm doing csv.head, and this head function will give me the first 5 items in there, right? With all of the columns listed and a handful of items. Go down a bit more, and I can see I have the .info function. And what happens, it tells me, here's all the columns, here's how many items is in each column, here's how many null values I may have, and then here's the actual item type for each column. So super, super helpful. So what I did was I imported all this data. I had never seen this before. I'm just trying to make sense of this. This is a giant warehouse. So I'm grabbing all these different CSVs. Then what we decided to do was, I think this is the one I actually went with. Data frame, parcel, pick 2, and I call the function head. So I've started to get rid of some of the data that I didn't really think to be necessary. I'm trying to understand how is their warehouse laid out, and then how can I make sense of all this. So I go down a bit more, and now I'm going to start to visualize it using different charts. So you can see down here, I have quantity on Y, and which bay is each item located on X. So I'm just throwing things at the wall, trying to see what sticks. And that's a lot of what you'll be doing with data science. It's not like you're writing a C# mobile app where you just write a bunch of code. Okay, here's a button, I'm good to go. This is more like, well, people just threw a ton of data on the table, pick it apart and see what you can come along with. So this might be useful for maybe a customer I'm working with to do before I get there. And then from this, they could say, okay, from all of our data, here's some charts and visualizations. So here's a particularly useful one. Here's everything we've come up with. based on this, I'll describe what this is in a moment, we would like to optimize our warehouse. So we started off with, okay, we have a warehouse with tons of stuff. We want to optimize our warehouse. So what does that mean? So what we did here was we have a function up above, and you can see all this in my notebook again, where we did a heat map for the lane, so which aisle, essentially, versus time. So I want to understand how often are pickers, or couriers who are going through this warehouse to grab items, in different spots of the warehouse. The darker the color, the more heavily trafficked the area is. On the top there, that's actually the front of the warehouse. So imagine I'm a top-down view of this warehouse. If I'm coming from up here, from the top, that is the entrance. All the way at the bottom is the back of the warehouse. With me so far? So I'm coming down. We can see it looks like most of the heavily used items are in the front, right? So now we're starting to get somewhere. It took us a day to get through all of this data. We got to this part and we said, okay, now we're working with something, because what we could say is we don't really want to have any blue spots anywhere, right? You might think, oh, it's ideal to have all the blue spots, the heavily used areas right in the front, but at the same time, if everyone's trying to go to the same spot, you suddenly have a lot of traffic. Haven't you played SimCity before?
Yeah.
I played crazy amount of SimCity. Just bought a new one called Cities Skylines, which is like the exact replica of it. And it's a simulation of the world where you're building roads and highways and cities. And I spent like 3 hours today playing it again. And it's so similar to this specific project, because the traffic and the congestion, the second you clear it up, you see a heat map of how dispersed all these cars and these people are. That's what I was trying to do here. So now we narrowed down their problem. Again, that business book, not everything's machine learning, but at least at the beginning this was. Said, okay, everyone is hitting the front of this warehouse. How do we disperse these items more evenly? Okay, so now we're getting somewhere. But again, I wanted you to be aware of some of the tools that we have. So in this case, I have this notebook. I'm running it in the cloud. You can hit download, pull all this stuff, and have it run locally. But I comment along the way because I want their engineers to understand what's happening. I want them to be able to give this to their management, and they can very easily understand what's happening. I'm running short on time, so that's why I'm speeding through this.
15.
Oh, 15 minutes. Okay, cool.
Can they collaborate with you on the notebook at the same time?
No. I wish they could, though.
But you're going to fix that, right?
Ideally, right? I mean, you could use WebSockets, right, to communicate in real time in the cloud. But with this, no. You cannot have two programmers work on this at the same time.
That's not the free version.
What's that?
There are Jupyter
We can do this.
implementations that can do that, but
That would be
is
helpful.
not the Azure
Right.
free notebooks.
Gotcha.
Yeah, because that's something I need to look into then, because that was a question that came up as well. I would love to be able to work with someone simultaneously on this.
Your question is like Google Docs style is
Yeah.
everything. Yeah.
They're
Or the-
Jupyter
notebooks.
It's
Yep.
always described as Google Docs, despite everything
that's-
Microsoft has done.
The point is
Yeah.
people do instantly know what you're saying, even though we've got Office Video Live Share coming, we've got the similar features in Office Online, but I was just at a hackathon with high school students, and they actually asked me, well, can we collaborate on this Google Docs style, right? Instead of I want to work on it on my so it is kind of a known quantity, but
Yep.
but
I
yeah,
agree.
that's
I would
what
say
developers
that's
want
The
this for
fact that
everything.
they know the word collaborate is good.
Developers want this for everything, right?
Here's another example of some of the work we did together. So again, I save these. I comment everything. I comment like a crazy person. Also, you see I'm kind of strict about how I line everything up too. For me, it takes me a minute, but it makes everything so much easier to read too. So again, same thing. This is the second time I went back. Scatter plot visualization based on data from June through December of 2017. I'm just gently going through this, but maybe I'll take some of these in another example and show you how we can get started.
So Dave,
Yes.
this fascinates me.
Sure.
You're trying to learn all this stuff as a Microsoft employee.
Mm-hmm.
Isn't there like a book at Microsoft that says this is how you go out and consult with machine learning?
No.
So they don't have like a department in Redmond.
Oh, I wish.
So you are the department. sort
Yeah,
of.
because there's such demand for the skill set, but so few people who understand
Yeah,
it.
I'm thinking of
Yeah.
a traditional large consulting company where they would have a best practices unit that would say, this is the way we want you to do
Lots
this.
of people are working on it.
Yeah,
Interesting.
it's like so cutting edge for us too that Yeah.
So you're making up as you go.
Yeah,
Well,
I
then
think most of them are.
That's Dave Voyles at Microsoft.com.
Yeah. Yeah, I'm glad to answer questions too. And the thing is, these tools move so fast. Even when I showed this to other coworkers, like, I didn't even know this existed. Because this tool is brand new as well. So again, a benefit of using this Azure notebook is that all of these Jupyter notebooks, these Python notebooks, I can run them all locally on my machine, no problem. But the benefit of having it here is now if I want to share it with anyone, if I want it to be part of a tutorial or a blog post or someone I'm working with, I don't have to give, send them the Python file all the time. I can instead just say, okay, here is the link to my work. You can run this. Even better, you can hit copy and it copies the entire thing. I'll show you the next step up. So look at this Kaggle Titanic. So Kaggle, fantastic website for learning, machine learning. I believe it's also owned by Google. I think so. So here, this is an entire repository, and you can see cloned from. Let's click on it. So this is a gentleman's tutorial for Kaggle's Titanic data, machine learning from disaster competition. So Kaggle, great website, and I'll go into what that is. Great website for data science, machine learning, Python, the home of data science and machine learning. So what this site does has competitions and data sets that you can use all the time. For learning, there was one I did a project on with an insurance company. I'm drawing a blank on them. They had like 10,000 images of distracted drivers. State Farm, that's who it was. Let's look for this. State Farm. State Farm distracted driver detection. So what they did on a closed course is they had all of these images taken, and someone's basically being pulled along in a vehicle with just kind of tractor thing in front of them. And it's designed to simulate real world experiences, right? So they have a camera there, this person's a test driver, and they have something like 10 different scenarios of being distracted. One's like eating, the other is cell phone, the other is looking down at the radio. So what you have to do, it's a classification problem, is can computer vision spot distracted drivers? So it looks like they did this competition 2 years ago, 1,400 teams entered, grand prize $65,000. So they'll say, here is, the terms of this. So here's the evaluation. Here is the math. If you asked me what this math was a year ago, I'd say, right, they're trying to do multi-class. So again, remember I said there's like 10 different classes of distraction. So based on those classes, you've got to determine on a bunch of data, specifically the images, you need to build a model, a function that is going to learn from those images, and then any image you pass from that on has got to say, I know what this is. I've never seen this image before, but I know that this is a picture of a person who's looking at the radio, okay? As opposed to a picture of a person eating a sandwich or looking the other way. So they'll show you exactly, here are the 10 classes. You need to predict what each one looks like. And here is the header should say image 0, image 1, image 2. So they give you a very clear understanding of how this all should look. Here's a leaderboard for people who are submitting their own models to see how it tests with others.
Brazil.
Yep, so let's see what... I can't actually click on those yet. But the kernels itself, here's some of the math or the functions people have written. So let's see. Here are the different libraries and frameworks that people have imported. It looks like a lot right away. I'm not going to get to what all these are just yet, but some of these you've seen before. I mentioned pandas, scikit-learn, I mentioned before. Do anything with deep learning, scikit-learn, or machine learning, scikit-learn to be your go-to. Keras is a deep learning tool. So again, people are kind of in a competition with one another here, but at the same time, you can see other people's work. They're more than happy to share it with you. And especially a couple years after the fact, they really don't care. So a lot of it is collaborative. State Farm, can use this as a great tool to recruit people, maybe make their company look very attractive because these are some of the fun projects people are working on. Netflix does the exact same thing every year where they have this machine learning competition. And a lot of the engineers or data scientists who submit their work will actually outperform Netflix's model, but it's so costly to implement that they don't actually do it. But at the same time, like if you look for Netflix ML competition. Netflix prize. And here we go. Netflix prize data. Kaggle. $1 million. And you can see, here's the run a month ago, this movie recommendation engine. So people are sharing this all as notebooks. That's a good way for you to get an understanding of how a lot of these tools work too. So anyway, this GitHub repository was based on one of those competitions. This person put together a bunch of folders, the whole Python project, the README. So it kind of gives you instructions on how to get this running. See where it says like activate the environment, pip install, this and that. No, don't have to do any of that. I will show you. Let's get this URL. I am going to go to Dave Voyles. Let's see. There's usually a button for new libraries. Maybe. See what happens. I take a day off and look what happens. So let me see. New. Or maybe I hit the limit. That might be it too. Add items to this library. No, not what I wanted. Oh, here we go. Dave Voyles libraries. Hit new library. GitHub. GitHub.com/ the gentleman's name. Kaggle Titanic. I'm going to say Azure Meetup test lib. And then it's going to be stored under Dave Voyles libraries Azure test lib. Import. It's going to take all of that code, copy it over to my Azure notebook. I hit one button, all of that runs. Could not be easier. So that's how I started working with the Titanic test data. Is rather than me go over and get a zip file and then import the zip file and have it run on a VM somewhere. I hit one button, import. It'll all be there in just a moment. Actually, there it is. That's it. So the whole thing works. And now if I want to see, he's got Python examples. Let's go here. So AGC embark class by gender. So here is an example of his thing working. Let's go to run. Nope, this is definitely not what I wanted. Oh, it's just Python. That's why I hit a Python file. I need an IPYB. Oh, here we go. Titanic.ipython. That's the extension I'm looking for. So I cloned this GitHub repository. It's running my Azure notebook, which again is essentially a Linux VM in the cloud. And here is all of that code. So this is essentially the markdown at the top. I go down a tiny bit. I'm going to zoom in here. Here are all the frameworks and libraries that he's importing. So remember, I didn't have to do all the installations, pip install, and nothing like that. What I will do is I'll do Control-Enter to run. You see this little asterisk that's happening? That means that cell is currently being run. So right now in that VM in the cloud, it's importing all of these different libraries. If for whatever reason it's not installed, see that one tells me that it's finished. If for whatever reason something isn't installed, I could go like this, bang, and I have access to the bash terminal inside of here. So I could say pip install, let's say pandas. Requirements already satisfied. Okay, already has that framework. Good to go. I could do bam, ls. Oops. And it's going to show me all of the items I currently have in that directory as well. So everything you need inside your bash terminal, good to go right there. So imagine how much time this has saved me already. If we were going to code together right now, you could bring any machine you want. As long as you have access to a browser, you're good to go. So this has saved tons and tons of time. And again, I can see how this developer is working. He can write tons of comments here. So for a production model, this probably wouldn't be how I would do it. What I would do is I would take all of the code, strip out the comments and the markdown. I'll put this into a Python file, and I then run that Python file on a machine, probably somewhere in the cloud where I'm going to get most of the bang for my buck. With me so far? Okay, so we talked about some of the libraries. How much time do we have left? About 2 minutes? 3 minutes, perfect. So talk about some of the Python libraries, some of the tools that are available. Again, what I like to do is, as I'm watching those videos, I keep two monitors up. I have one with those videos on from Udemy, and the other side, if I go to libraries, you can see, let's go to 0 to deep learning. says stopped because this virtual machine is not running right now. But what I did was I copied a bunch of that code over. I go over to course. And then here are all the Python notebooks that this developer has made. But I created a folder for myself called code along. And now I can go to fully connected dense layer. So this is one that I was working on last week. So on one screen, I'm watching the videos, understand what's going on, and then I'm coding along with this person. And they have exercises along the way. They'll say, your problem is X, Y, and Z. We want you to solve that. And this is me solving it. So I'm going to write on my code, fully connected layers. All this code actually ran previously. And you can see all the visualizations I have. Accuracy, training, and validation. Again, too much to cover right now, but I wanted you to be aware that I've just run a bunch of deep learning on someone else's virtual machine who's footing the bill for this. And when I really need the good speed on this, I can put this on a virtual machine of my own. So that's essentially what I have for notebooks here. Again, I could spend several more hours showing you how virtual machines actually work for this. Azure ML Workbench, so you can run this code locally, put it into Docker containers, or even take a Docker container, push it up to the cloud, and run it there. This way you don't have the problem of, oh, it works on my machine, right? That's essentially what Docker solves, is that you have the same environment regardless. So now I could build this locally, build a container, push that container to something like Docker Hub, and now, boom, everyone can run that math on the model that I've just created. With me so far? Just touch the surface. More resources, my website. Oh.
Thank you.
Cool. Awesome. Thanks, Dave. We're going to do a quick switch over and let Zach get set up. He's going to slide in here and plug in. So we'll do that switch.
So for Philly to know.
And while we're doing that, I just want to let everybody in the room know.
But there's more if you want to, too.
Come around. You'll be fine in the HDMI.
Yeah.
No code stuff.
It's right there. I want to let everybody know we have
That's why I'm
a
doing this because
very nice gift from Microsoft, which Dave and Rich and any other Microsoft employees can give out, which is 3 months of Azure credits. It's 100 a month for 3 months.
Redmond telling you what to do.
Free on them. And the cool thing with this is normally when you sign up for Azure, you have to put in a credit card. This you don't. So this you can sign up for free without putting in a credit card. Try it out. So senior persons, hand some out. Give some to Dave. Dave, you can give some of these out. These are from you. These are
Beautiful.
from Microsoft. So please give them out. And I'll say
I
hi.
sent you an email.
Good presentation.
Thank you, sir. Trying to learn as I go.
Cool. Thanks everybody for standing by online while we did a switch. Thanks everybody from the room for listening up. Lively conversation. We are back with the second presentation of the night. We're going to try to get through this by 8 o'clock. And again, then we can chat afterwards. So this is now Azure Data Catalog with Zack Fanelle. Am I saying that right?
Fanelle.
Thank you so much. Go ahead.
Hello everybody. My name is Zack Fanelle. And I'm sharing with you today a little nifty tool called Azure Data Catalog. It's a very simple tool, but its purpose behind it is actually very powerful and very important, especially like when you're doing data enterprise projects, moving to the Azure Data Catalog. So my background, I have a background in business intelligence and also cloud computing and DevOps. So I sort of have done those two worlds, and throughout my career, a lot of the problem I like to solve is how do you get the right information to the right people at the right time? How do you do that efficiently in the back end, building all the databases, your ETL, a data source, and how do you do it on the front end? How do you build the visualizations? What people actually need the data? So that's the problem I am most passionate about and what I work to solve, and especially with cloud computing. It's like cloud computing is like the steam engine in the Industrial Revolution. You achieve such high levels of efficiency that, like if you were to start a business from scratch, the default would be you would probably build, just rent servers either in Azure, or you would go as high level as you can, either software as a service, platform as a service, and if you can't do it infrastructure as a service. There's many reasons, economies of scale. So at first, this may seem like a very vanilla tool compared to a lot of the Azure offerings like Cosmos DB, Power BI, and things like that. But this is sort of the tool that is sort of useful in the enterprise, like when you're building reports, you're architecting your data infrastructure, you're an end user building data. This is who this is for. So let's go and see why this is such an important tool for enterprises and maximum organizational efficiency. So before I begin, I'd like to ask the room, just get a show of hands. I want to see like what the room is sort of about. See who's developers, who's in the operations, analytics, and managers. Who by here is developers? How many developers are in the room? Okay, so about a third to a half. How about operations, DevOps, that sort of thing? 1, 2, 3, so we have a few of those folks. How about people in analytics, either building big data, either authoring dashboards, anything, okay, so 2. And then how about managers? Okay, so we got a few managers, all right. So let's begin. So as we see, like, why is cloud computing so important, and where is Azure in it? So as of now, in terms of public cloud revenue, Azure is about 10% and AWS is about 47%. I recently saw recent data that Azure is about 15% in terms of adoption. It is growing, and Amazon Web Services being about 42%. So as we could see that Azure is gaining momentum, and a lot of the reason why we can see this is because I try to find some hard data on this, but it's so hard to quantify. I can only use anecdotal evidence, and what anecdotal evidence you guys have is in an organization, like the big name that we see in comparative all products is usually Microsoft, like in terms of desktops, software, Excel, SharePoint. I mean, Microsoft is such a huge and foundational piece to almost every organization. So with that in mind, in Azure, in terms of building solutions, you're going to go with the solution. You're probably, especially if you're newer, going to want to go with the solution that is not just like established, but also a lot of the pain points. It's not usually the best product, even though Azure is very good. But what is the least painful way you can get to the cloud? And that's most likely, do we have a question?
The IBM Watson should be in this one or in others? IBM Watson?
IBM Watson?
Yes.
IBM Watch.
Oh, they're
It should be the software, should be in others.
That's one of the others.
Blue mix.
Yeah, I'm not sure. They might have categorized that in other. I'm not sure. Where they
have
want to
better
put it.
commercials.
Huh?
They have better commercials.
Yeah.
You're talking cloud providers versus service.
Yeah,
This
this is this.
like, cognitive services thing.
Yeah, this is cloud. This is for provided by Cloud Revenue. I just wanted to show where Azure is sort of at in comparison to the whole ecosystem. Like, it is small, but going from a business sense, organizations that aren't in the cloud, Azure would make a lot of sense just because there's a least amount of pain point to get there. Like, that's such a huge and foundational factor. So many new things are now possible in cloud environments. Let me give an example. So for this Azure Data Catalog, you can have business users actually actively have read-only access to Azure. So they can take a look at data. Business users can now, you can give them very easily in Azure as opposed to like an on-premises solution. You give them read access to look at everything. So they can see all the data and everything available. But if you see sort of everything available, there's no sort of organizational structure. And if you look at how BI was before, the IT owned it because the data was not accessible to end business users, and it wasn't accessible, and they didn't know what was out there. So let's talk about data cataloging and sort of, why is it important? So first, just really quickly, data documentation, documenting the database around your organization. Does anyone have any, just really quickly, does anyone have any reason why it would be important to document your data? What tables mean?
So you can find it again.
Yes, you could find it again, but like for like a, give me like a situational.
Well, I mean, for data privacy, understanding what data is, allowed to go, stay on-prem, allowed to go into the cloud. If you're residing in different countries,
right?
GDPR comes into place. So if I'm deploying compute instances and marrying my data to those compute instances of my applications, I need to understand, what can leave Germany, what can stay in Germany, right? What are the laws? What do the laws dictate based upon the industry that I'm in?
Right. Yeah, that's a very good reason. Like when you're developing solutions and you need to know what data to isolate and where, that's going to be very important. Just some other reasons is, data is used by all layers of the organization, whether you're a report builder, you're a developer gathering the data. You need to know what the data actually is. So there's many different reasons. And in order for your organization to be objective, you need your data to be reliable. So it needs to be, and not only that, it also needs to have context. If your data does not have context, if you don't know what it means and what it means, it's going to be totally useless. So if you want to be an objective organization with business intelligence, essentially applying the scientific method to your business, measuring something, building something, growing your organization, you need to be able to filter that out to everyone in the organization. Everyone uses data, from the operational tracking developers to people analyzing data to managers actually consuming the data and executives. The data needs to be accurate for them to get the right information. So let's go on to some simple use cases. So why would you actually use a data catalog? There's three sort of important use cases, and there's probably many more than this. The first one would be, and this is what to me is the most important as a business intelligence practitioner, is the self-service business intelligence model. BI is just getting the right data to the right people at the right time in the organization. And in order to do that, you need to be able to do that in a very fast way possible. In the past, IT would design all the reports, they would own all the data, they would design the ETL, they would do everything like that. And now we have a new model called the self-service business intelligence model. And what this looks like is us as IT practitioners, databases and ETL, that's a little complex for the business to be able to own. So we would essentially always own that. But gathering requirements and finding out what the business actually needs and building the visualizations, that's a little complex for us in IT to actually own. So the self-service business intelligence model bridges those two gaps, where what it essentially looks like is us as IT practitioners, we own the data source in the ETL, and they author the visualizations, they author what they actually need. So we actually build the data source for them. So in order for us to actually build the data source, we need to author what the data actually means and tag it, and so that the business will be able to search of the data sources that we build and be able to tag and understand what these sources need. That's one use case. Like if you want to build a maximum efficiently business where you have data, you're building reports at the highest speed, accurate reports, and keeping your business very happy, you'd want to adapt this self-service business intelligence model. And if you don't have your data documented or authored, it's going to be very hard to do that. The second one is more for us as developers. Is we want to add a new column, we want to remove a column, like let's say like from a table. The impact of changing data in the back end is huge. Like if you adding or deleting a column, like that could break an application. And we change impact. I've been on a lot of projects where if we add a table or we remove a column or add a column to a table, what's going to happen? We need to be able to do impact analysis is very difficult. Having your data documented is going to be very important, and to be able to do that analysis. And the third would be just the same thing for development documentation. You're a developer and you're building applications. You need to know what your data is in the back end and able to build useful applications. So these are sort of three different practices of how a data catalog is actually used. It's not just one use case. You could use this across many different use cases for your environment. So definitely keep that in mind. Documentation, this isn't just for a small, this is a small tool, but it has a lot of impact for both development and the end users. Any questions before I move on to the next slide? Any comments on this? Okay. All right, so where does this tool actually fit? So we talked about how big Azure is and how big it's growing. So what would this actually look like? So we have your data sources, as we see in the bottom left corner right there. These are the systems, and then we have the subject matter expert. A subject matter expert would be your analysts, even sometimes developers. And what they would do is you have a one-time registration of your data sources, and then you would sort of author them, add what the names of the fields are, what they mean, a description, adding context around your data. So whether you're building a report as a business user or you're a developer, your whole enterprise has a central repository into what exactly the data means. And if you've been on a lot of development and analytics projects, I know that they have so many different names for what revenue actually means or what field detonates at the actual money. There's so much miscommunication, and with this sort of a central data repository, there'd be no more of those debates, and everyone would have access to. We would have a golden copy as to what the data actually means, and the subject matter would author that. So we also have in the top right corner there, whether you're a developer or you're a Power BI, you would be sort of those would be the end users or the consumers. People building those tools, using those tools, would be the end users of this tool, and even developers. And subject matter expert would be expected to both be business users, analysts who need to know what they want to capture, and then also the developers who can actually see the data in the back end as it's being captured. So just reading. So before we move forward, I was about to make a tech demo for Azure Data Catalog, and one thing you definitely need is, I was going through it and authoring some, annotating some databases, and you need Azure Active Directory, and I saw like a giant char. I created one. Oh, let me create one, and then there was a giant charge, and I'm like, oh god, I gotta close that before I get a giant bill. So there really wasn't, I played with it, there really wasn't too much there. I figured images would probably be just enough, and I also didn't want to get charged too much. But one of the prerequisites is Azure Active Directory. So let's move on to what are the three components of this tool. So when you're authoring and with your organization and you want to annotate what's going on in the background, there's three things, there's three major activities: registering, discovering, and annotating the data. The first one is registering the data. You have a new database. You want to say, hey, you want to bring this to Azure Data Catalog attention. That's the first thing you do is you register data. It's a one-click thing, very easy. As you see this going forward, it's actually a very easy tool to use. The challenge is getting the organization to use it in the right way and to be disciplined to be able to use it. But when people actually see it and use it, they'll see how powerful it is. The second is discover. So when you're building visualizations, and our users need to, so you have your catalog there and it's all annotated and everything like that. How does your users actually find out what, like let's say they're looking for revenue fields to mask or something like that? How do they actually go in and search that? So there's many ways to do that. You can discover, if you tag your data correctly, you can search by tags what exactly, as you pointed out, what fields are sensitive and what fields are not. And to be able to do that with an instant click as opposed to sending your IT and business analysts weeks to comb through everything, it's absolutely huge to be able to do something like that with a click of a button, especially with all the data projects that you're building, be it in development or analysts. So you need a repository to be able to search. And the third thing is annotating. So this is adding context to the data. So there's two, I guess, sort of authors who would do this. The first one would be the developers, the people who actually know the source systems and what the fields actually do. They would provide context on what the fields mean technically. Also, your analysts, the people who consume the data, the people who could look at development in a field and say, oh, we don't use this field for that. We don't use this. We don't use this field for that. Like they would add the consumption layer. So there's two sort of users that would sort of annotate it. And this is a dual use tool, as I said, both for the business and also for IT. So another really big thing is tagging. You really want to tag your data, whether it's a field is private, if a field has to do with a certain project. There's many different kinds of tags. You can get very creative with it, and doing this forward for many different projects makes, especially the change impact or building something new that you don't know, it makes it very useful. Any questions?
For the discovery layer, is there any type of provision to maybe create a commonly searched for set of data? So for instance, I'm looking at some of my kind of business departments, and they'll often ask for a certain set of data. We'll create a report that matches that. But if all of the data systems are registered, the proposition here, and then say somebody outside of that business department wants to know the same report that we've been asked for from the business department, would they be able to discover existing reports or existing queries as well, or is it just data sources?
It would be just data sources. Okay. So this would be so someone very, I guess, like a manager or an executive would not use this tool. This helps the analysts and developers build it. So on a report level, that's not there yet. That would be a very good feature to add, is to be able to tag even Power BI reports in this. That'd be a very cool feature, I would think. But this is a tool. It's going to help you get there. Like if you're authoring your data, this is a tool to make it efficient for report builders and developers. And the managers are going to be like, why is this useful? But they'll start seeing it's useful when they start getting their reports faster and development projects moving a lot more efficiently. That is, if I was to present it to a manager, I would do it that way.
Okay. So, in a discovery, is it going out to like a data lake and saying, I understand that for finance has a data lake, and that data lake is broken down into, operations, back end, whatever, worldwide, and so then it's allowing you to discover that these data sets are available for finance here. There's another set for operations here, and then it's taking this data and allowing you to then extract the information or put it into a catalog that people can subscribe to. Is that it? Yeah,
that would be a use case you could do it for. That you could tag, like with tagging, you apply your own meaning to it. So you could say this data is used by finance or something like that. But I guess it would mostly be used for what fields actually mean, what the originator of this, what the source of this data is, what a field.
So you have a schema that's already been predefined, and you're basically reading off the schema.
Yeah, you're reading off the schema essentially. Yeah, but this tool takes that schema and it like a business user is not going to know like field names and stuff like that. They need a searchable repository, and that especially becomes useful in when you're building self-service business intelligence tools. When you give a data source to a business analyst, they now have meaning and context to the data. And then also for developers, they can take a look at if they're starting a new project and they're building a new website and they want to know like what the data actually means to the business, they could look at this tool and look at the description of all the fields on the meaning that that the analysts provide to it. So it's sort of a dual thing there, is the analyst providing their meaning to the data and the technical people providing their meaning to the data. Or you could use it as organizational, like you can say like this is finance. You can organize it any way you want, but practically it's going to be for those two sources to provide meaning to each other. Any other questions? Okay. So let's, I'm going to show some screenshots really quickly. So wish we could sort of zoom in here. So let's go to the register thing really quick. This is very, very simple. You add your data source. So unfortunately, data catalog, you can only use it for Azure data resources. But this is especially, a lot of people are moving their on-prem into Azure. So there's, that's why I sort of picked to talk about it, just because the rate of moving so many resources to Azure. So that's what's one downside. So you pick your data sources, and let me show you a quick list. So this is sort of what that screen would look like. I was able to do it very easy with Azure resources, but more useful, you could sort of see what you can annotate. So there's a lot out here in Azure is what you can annotate: Hive, HDFS, MySQL, Oracle, and you can do it by manual entry or the registration tool or the API, SQL data warehouse views. Like as you can see, there's a ton of data sources that you can that you could search for in Azure. So the registration is very basic. It's just adding data sources. So that's the first thing. It's just adding data sources. So the next thing would be sort of the discovery, and this is what sort of this would look like. Is there's a lot of search, and as you can see, you can add a lot of annotations, tags, as we see right here, tags as to what the data is. This is very basic. Like in a real deployment, you're not going to say sales and finance. It's going to be a lot more complex than that. It's going to have a lot more specific meaning, but this is on a sample data set. It's going to be, it could be project name, it could be division within the company, it could be many different things, however you want. Ownership, who actually owns the data, region. There's so many different, data is so complex, there's so many different meanings that you can apply on top of it in terms of context, and tagging is a very powerful way to do that.
Does tagging allow you to apply security trimming to your schema definitions here? Like if, for instance, you wanted to prevent certain groups of authenticated users from seeing the schema definition for reseller total sales, could that be applied either per tag or for some other mechanism?
I haven't come across that. That's a very good question. And he's asking if Charles, right?
Yes. Yep.
Charles is asking if we don't want to expose our whole schema to the whole organization. Is there a way to say there's a new let's say developer, and we don't want them to see the sales data? Can we prevent them from doing that? As of now, I don't think so. But there's metadata here, but there's not data. So
okay.
They won't get to see the data, but they can see the metadata. And there's a big tagging. The cool thing is that this is there's like every single one of its own databases, like Oracle. They have their own sort of dictionary where you can define what data means, and this is cross everything and within a cloud. So it's very extensive. Any questions on discovery? Okay. All right. So we'll move on to annotating. What does this look like? So as you can see here, when you annotate your data, you can add My screen's a little broken up here.
Text box.
Yeah, it's I don't know how that got there. Remove that. I don't know how that got there. So this is what sort of the annotation screen looks like. You can add, in addition to tags, and I think this is almost the most important, is adding descriptions, what a database is actually used for and what it means. You can do this on the database level, the table level, the field level. You can add a friendly name for a field as to like a business friendly name. And a business friendly name is very important, especially when you're working on data projects, even data science projects, when you're trying to figure out, hey, like we want to figure out, even in data science, you need to know the context of the data. So this gives a very definition as to what you're actually capturing in your organization. So that to be able to name and apply meaning on all levels of data across many different data types across a whole entire cloud deployment, that can be very revolutionary and open up self-service business models. And when you have data that's this open and this well documented, the levels of efficiency of your business are going to go so high because people will be able to serve themselves instead of asking around. Everything will be there.
So things like this description or other tagging, are they crowdsourced from throughout the organization? Is that, or from users? Or is that how it comes together?
That's essentially what you would want to do. You'd want to crowdsource. You want to put the tool out there and crowdsource it in the sense to the appropriate people like developers and the analysts. So as you're going forward, they're both going to have, like as a developer or as a business analyst who's building stuff, you're going to want to apply two different meanings to this data. So there's a dual use here. So
is there a function that allows you to clean up the data before you categorize it within this platform? The problem is that 90% of the data lakes are junk, right? So
yeah.
if I have the ability to clean up my data before I federate it, right, in a catalog form, that would be useful.
So that would go back to when you're adding data. When I was doing it, you can add, when you add the database, you could have it scan the whole thing, or like the database and scan everything in the data lake, or you could say only scan these three things. I don't think it would be intelligent enough to know what's useful and what's not. Is that sort of what you're asking?
This is where Dave comes in.
Yeah. Yeah, it doesn't have
Dr.
that
Dave.
level of intelligence.
It's Dr. Dave now.
I wish. I don't have that many student loans, so I just paid them off.
So I remember when I was developing, when I'm building BI projects or I'm developing a data solution or a cloud solution, to have a resource like this to be able to find out what the data means, you could take a team of like a huge team and shrink it really small, because now you can have one person instead of sending all these analysts to figure out whatever. That's what you're doing a lot. Think of how much of your day you spend figuring out what stuff means in an organization. It wastes or not waste. I don't want to use the word. It consumes so much of your time, and to be able to have a tool like this to be able to tag data, the most asset that we all use, especially in an organization, is infinitely valuable. So as we can see, it's a very simple tool. It's not. It's just a tagging tool, a very documentation, but its use cases is so powerful, especially if you apply discipline to your organization. Any questions? Oh, go ahead.
So you brought up, IT would still continue to own those ETL scripts and the processes and the databases behind the scenes. Does this provide an easy way to see which sources are connected to which targets inside of that ETL scope? So for instance, if my HRIS is connected to a separate payroll system is also connected to Active Directory, can I see kind of the property or attribute mappings of the entities in each of those objects if there is an ETL kind of configured there? Is that something that can be defined in this schema?
You could do it through tagging, but as of this, like this doesn't. It's blind to ETL. It just looks at the data sources. But that would be a very cool feature to add to this. Is not only because like a field in a database, like how did it get there? Sure. Where did it come from? I mean, that's what tagging would provide. Okay. But if maybe it would be very useful if like Azure has its own like data factory, its own data tools. If it could be intelligent enough to look at it and define where it actually comes from dynamically,
And show
that would be huge.
relationship would be awesome.
Yeah, to show that relationship so you don't have to manually do it. That would be huge. That'd be very big. Any questions?
Yeah,
Go ahead.
I have a question. I'm looking at the pricing, and it says it's free up to 5,000 catalog objects. I guess, what is a catalog object? Are those going to be, if it's a relational database, a bunch of the columns and fields? If it's a model, it might pick out facts. Are each one of those counting up into the 5,000?
I believe an object, from what I remember, counts as a table.
Really? So it's just 5,000 tables then are free?
Yeah, I believe it's a table. It
relational.
might be a column, but I remember when I was doing it, I believe it was a
Well,
table.
I mean,
I don't
the
trust
picture here, those look like fields. Some of them anyway.
This view right here these are databases. So
The whole thing is a data. Well, total inventory optimization, or whatever that's about to say on the left.
No, it
there.
says product inventory is contained in database adventure work, so that is a table. It says
Oh,
SQL
these are-
Server table.
oh yeah, you're right. These are table. I thought these were.
Well, that one even might be a field, or maybe but you're right. I mean, it's definitely inside a database.
Yeah, I created this view right here like that. This level of detail with tagging and description is available on all levels: the database, the data source, the database, table, and then fields. So, here we go. We have it right here. A catalog or an object or data asset is the metadata representation of a real-world data object. So this includes tables, views, reports, and so on. So, so it's 5,000 tables, not 5,000 fields.
That's quite a bit.
Yeah, that is. That's a lot for free. If it was fields, it'd probably be very few.
But
You'd probably go for that pretty
but
quick.
Azure Active Directory is not free.
Yeah, that's why I made it.
Gotcha.
Yeah, that's why. Yeah, Azure Active Directory. That's why when I was making a presentation, I was playing with it. Like, oh, this is cool, and then I saw my bill, and I'm like, oh, gotta get rid of that. And I made it so early, like
If your organization already has that, though,
Yeah.
it's a pretty good, it's a considerable offering.
Yes.
Yeah, it's a very good offering. Any other questions? Okay. All right. So the next slide I'm going to go through is sort of features that aren't there, but I wish were there, and there's so many creative things that they can do with this. So just sort of three that I just thought of the top of my head is Power BI integration for data discovery. So if Power BI was smart enough to look at your Azure data catalog and you'd be able to pull in and look at all the data sources and say, ooh, I want this in here, that would be awesome. Because Power BI is such a big tool. To be able to have the self-service BI, this catalog integrated in Power BI, if there was functionality there, you would be able to get to whole new levels of efficiency. That would be very cool. On-premises capability would also be very cool. Like, we want to be able to do on-prem. We're not off those. And then the third one would sort of be joining fields. So when you have a relational database, the data catalog, I didn't see it can't support this yet, is like when you have a relational database and you're joining fields, what fields are actually related. If it had that capability to be able to see joins and how the tables are related to one another, that would be super cool. That would make that'd be a little more useful maybe for developer side, but that would be very cool if they add that. And as we saw here, everyone else had a different idea, lots of different features to add, like with ETL and things like that. So I only see a way up for this. It's a very small tool, but in terms of productivity, it's huge for your organization, especially if you can do this in the business and get people excited about it. It was, just finding an ER dot, it would be especially useful when you're moving to the cloud. You're almost starting fresh, and to be able to do something, if someone do a data cataloging project on everything on-prem, that would be like that would be too difficult and people get tired. But when you're starting sort of fresh on Azure, it would be a very good chance to start documenting your data. So that's all I had. Does anyone have any questions?
Do you see this I didn't get a good glimpse at all of the supported data sources, but
Oh, sure. I can bring that up.
you know, one thing that comes to mind is we have so many of these kind of users doing something ad hoc as far as data collection or building their own kind of Excel workbooks and sheets like that. And, you know, that's great up to a point where it's organic, but then it becomes, you know, a business function or a business critical function. Would you see this as kind of a way to document some of those existing user created processes? Like maybe they've got an Excel sheet with 5,000 records in it that really does need to move into another system, but we could at least catalog it temporarily in sort of this data catalog. Is that a use case that you might envision?
I would think so. Doing especially that sort of documentation, this tool sort of brings out tribal knowledge and makes it to the open. So I think
Is
an Excel
on there?
short. I'm sorry?
Is Excel spreadsheet a supported source?
No.
It's hold on 1 second, let me see here. This Collins.
You have this.
I hate to have to even ask the question, but
The answer is no.
Yeah. I'm surprised they don't have that.
It's a sink, but not a source.
okay.
Yeah.
It's a destination.
Okay.
It gets around the whole idea of governance. That when it's corporate data that is well understood and that it's coming under a corporate view, that's probably where it should enter into some sort of a cataloging view. When it's just, as you said, tribal knowledge, that's before, and once you do that, you can move it into it.
Sure.
But this is more like, okay, this is what is understood, supported, and you have some idea of its quality and its usage.
Sure.
Mm-hmm. Yep, and a data can be, as we saw, data. It's not just used by, it's used by everyone in the organization. To be able to create that and bring that out in the open would drive a very high levels of efficiency. Any other questions? All right, thank you, everybody.
Awesome. Thank you all.
2 minutes.
Appreciate it. Quick, one more announcement about these. They do expire to activate them on the 26th. So check the back if you do plan to use your Azure credits. They are good for 3 months, but they we have that. And next month, again, thank you all for coming out. I think there's going to be a small meetup afterwards if you want to join. And again, once more for around the room, if you are looking to hire or you're looking for a job, raise your hand, find each other. There we go. All right.
Which one's which?
Thank you.